Hey guys, it's Abhilash this side. I'm the physics head at the askIITians. And today we are starting with the most important chapter of our 10th grade, and that is light. Before we go deeply into this topic, let's have a bit introduction about this topic itself. So, to begin with, the most basic question, what is light? If I ask you. So I'm pretty sure you sitting over there must be giving an answer right now that light is something that enables us to see. Well, that's true, but the question still remains unanswered. What is it in the light that enables you to see everything? What light is essentially? Then some of you might be answering, well, it's the form of energy. Well, again, energies are of many types. There are potential energies, kinetic energies, heat energy. So, how do we differentiate light energy from others? So, well, if you're now finding it pretty difficult to answer that what light really is, then don't be surprised because this has been the most discussed question in the early 16th century till date. And I'll start all the way from the 16th century when the fight started between none other than Newton. Newton, first of all, after giving all the classical mechanics concept, came up with this idea that, okay, now light is something that remains unexplored. I must try and explain it. And he gave his own theory. He said that light is made up of tiny corpuscles, tiny particles. But his theory came out to be wrong. So then came another scientist, Huygens, physicist, I should say, and Huygens proposed his own theory. He said that, well, light is actually wave. And what kind of wave? Well, during those days, we had no idea about anything about electromagnetic wave or what it is. He just said that you go to a pond and you drop a stone and you see waves and ripples going out. Well, those waves and ripples, what we see are waves. Similar behavior is of the light. Light is also wave. So this debate actually kept on moving. Some people call light wave, some people call light something else, but this was finally solved by one of the most famous experiment, and that's Young's double slit experiment. Right now, we won't be able to explore it because we are limited with our current syllabus. If we get time, we will do it someday later. So, right now, what should we consider light as? Wave particle or wave particle duality? It's both. What should we take? Well, all these things are of the later part. Honestly speaking, right now, you can just consider light as a ray. A ray is coming in and doing all kinds of stuff, enabling you to see, bouncing off the surface, going from one medium to another. All these things will be done by this light ray only. So, for the timing, light is just a ray. Now, let's jump into the details of the topics that we have to discuss. So, light, if I talk about what all things come to your mind when you hear the word light, so you must also be saying, well, reflection is something that we have heard about the light. Refraction is one of the thing we have seen. Uh, Apart from that, you must have also learned something, and that is about rectilinear propagation. This very complex word you must be hearing. What is this rectilinear propagation? Well, you must have seen if you take a laser and you point somewhere, then laser actually moves straight. It doesn't go at an angle. A laser, although, is a complicated technology in itself, but the light ray behaves similar. Light ray actually moves in a straight line. Light ray never goes in a curved way. All right, unless you're talking about higher level stuff like black hole, which actually bends light ray. All right, if you don't go to a black hole, light will always move straight. All right, so let's jump into these concept. First of all, reflection of light we will be talking about, plane and spherical mirrors we'll be talking about, and then we'll be talking about image formation by plane mirrors. All right. So as you can see, the rectilinear propagation I was talking about. And by the way, there are easy experiments by which you can check also. Like as you can see in the image, you can take multiple cardboards and you can, make some of the holes in between in line and then put a flashlight and see how the propagation actually happens. All right. So moving ahead, reflection is the first concept that we are learning. So in reflection, it's pretty easy. You must have learned it also in your junior grades as well. Light ray actually falls at a surface at certain angle and then reflects off at the same angle. Here are a few things you need to keep in mind. There are three important terms. First is the incident ray, as you can see in the diagram, the blue colored ray. That's the ray which is coming in. Then there is this reflecting surface, which is most of the time the mirror, right? But it's not necessarily. You can also bounce light of a metallic surface, of any other kinds of surface. Only the efficiency of reflection changes. So a plane surface, incident ray comes in. Then how do we know what angle this incident ray is coming in? So then we have another term called normal, another line. Why it is called normal? Well, the word comes from the fact that the normal is always perpendicular to the surface. So if this is our reflecting surface, the normal will be at 90 degrees, the dotted line as you see in the diagram. So that's the normal. Incident ray comes in, comes at theta angle. Now this theta angle at which it came, we call it angle of incidence. Now we see how the light ray will going to go after this, which is what you see in the red colored ray. The light ray actually goes at some angle theta r, we call it angle of reflection. And surprisingly, both these angles come out to be equal. They are always same. Theta I is always equal to theta r. You have to keep certain things in mind. Both these angles are measured from the normal. So don't equate some other kinds of angle. Always equate the angles made by incident and reflected both by normal only. All right. Now, this is something we call law of reflection. Now, there is one more important point that comes up in law of reflection. It says that all these three lines that we have discussed about, incident, normal, reflected, all these three rays must lie in the same plane. Well, you must have read it as well, but I've seen it, people find it really difficult to understand what it actually implies. So, what it actually implies is, imagine this is your incident ray. This is the normal. This is our angle of incidence, and this is our reflected ray. So three rays. This is angle of reflection, angle of incidence. They are always equal. They are saying all of these three lines lie in the same plane. That means all these three lines can actually be drawn on the same paper. They lie in a 2D plane. Any of the ray cannot come out of this plane. Like I cannot have reflected ray coming out towards you. That's violation. Law of reflection. It has to be in this plane only. A plane. All three lie in the same plane. Nor can normal come out on any side, nor can incident ray go in and out. That's not possible. So that's what lying in the same plane implies. So moving ahead, following law of reflection, when light reflects, then interesting things tend to happen. Now, talking about from where it reflects, the best reflection happens from where? So then it happens from the mirrors. And we have three categories of mirror. First is the plane mirror. Plane mirror is something that we all use in our everyday life. You see yourself every day in the plane mirror. Second is the category which we call spherical mirrors. Spherical mirrors have two categories. One is concave, other is convex. So you can talk about convex and concave simply with a simple experiment, that is going in the kitchen, picking up a spoon. When the bent shape like this is facing you, that's a concave mirror. Watch yourself in that, how you appear. It will be pretty different from plane mirror. And then when you see from this side, the bent surface is towards you, then it becomes the convex mirror. So these are the three types. Now we will see what light ray does while bouncing off from the surface. What is it that enables us to see ourselves? What kind of thing is happening over there? So let's try to understand step by step. We need to understand that when light reflects off something, we actually see its image. Take, for instance, image formation in the case of like you walk into a dark room, you're not able to see anything. Why are you not able to see anything? Because there is no light ray to enable you see. Now, suppose you entered the room, there is a box kept over there, and now you switch on the bulb. Let's say here is the bulb. So the bulb is switched on. So what will happen? The light ray will going to come from the bulb and fall on this block. And then it'll reflect off that box, and then it'll reach to your eyes, and you'll be able to see that object. So you require light at the first place to observe anything. As long as this light was not reflecting, not bouncing off that box, you were not able to observe it. So that's the important criteria. Light rays enter in your eyes, and that enables you to see. Some of the objects which have their own light, which we call as luminous object, like this bulb in itself is a luminous object. Then some of them are non-luminous, right? Non-luminous means they don't have their own light. So non-luminous objects could be like this box, which was not visible in the dark because it did not have its own light. Imagine this box had some hidden light inside, so you would be able to see it even in the dark room. So that's what luminous and non-luminous implies. All right, now moving ahead, the concept you need to take away from here is when light rays enter your eye, you're able to observe something. So what if we talk about image formation by all these mirrors? How we are able to see anything in the mirror? So well, imagine you are standing in front of the mirror. You keep your hand like this. Now obviously you can directly see your hand. That's one view. Why you're directly able to see the hand? Because light is falling on the hand and coming directly in your eyes. That's how you're able to see it. You switch off the light, you won't be able to see your own hand. So that's one point of view. But the other thing that you will notice standing in front of the plane mirror, you will also see the same hand behind the mirror in the image, right? So how we are able to observe that other thing, that image inside the plane mirror? It even appears that there is some hidden world behind the mirror, but in reality there's nothing. If we go behind the plane mirror, we find nothing. So what is happening? Well, again the same thing. This was observable because light fell on it, came to your eye. The image is observable because light fell on this hand, went to the mirror, bounced off the mirror, and came back to your eyes. So again, I repeat, the image is appearing because the light that the hand reflected onto the mirror came back again. So one direct view, one is via a bigger path, going to the mirror and then coming to your eyes. So that's why you see two images. Two images, I should not call it two images. One is the actual object and the other is image. Okay, so now image formation happens when rays reflect off something and come to your eyes. So what way we can understand the image formation? Well, image actually can be formed in two ways. First is the real image. We can form real image. How is a real image formed? Well, like focusing light on a screen. Like every movie, every projector does this. Multiple rays are incidented on a point like this. And that point becomes the real image. So the concept behind real image is when rays actually converge, actually meet at a point, that's called real image. Then there is another type also called virtual image. In virtual image, the rays are actually not meeting, but they appear to be meeting. Now, how does that happens? So imagine that some of the rays are coming like this. Two rays I'm drawing, and your eye is here. You're observing from this side. So when you see these two rays, what your brain does is try to find out the source behind these rays. And your brain has this inbuilt programming that every time you see two rays, just try to find where they come from. So what your brain does, automatically it draws its path. it kind of makes a guess where they might be coming from, and it appears they are coming from here. And then that is what we call as the virtual image. Why we called it virtual? Because in reality, the rays might not be coming from there. Rays might be coming from somewhere here, let's say, like this. And due to some reason, they had a bent, but it made you appear as if the rays are coming from behind. All right, so that's the concept behind virtual image, from where it appears to be coming. And in reality, that's how the image formation also takes place in plane mirror. So let me talk about image in plane mirror. So if this is our plane mirror, then how can we imagine the image formation? So imagine you have kept an LED like this in front of the mirror. Well, it will be having a lot of rays coming through it. I just need two rays to show you how the image formation will take place. First ray will going to fall directly on the plane mirror like this. It'll bounce off according to the law of reflection, which we learned. This is the normal, isn't it? So at whatever angle theta it has fallen, the same angle theta, it'll bounce off. Incident and the reflected ray. And one more ray, which I can take, is directly falling at 90 degrees on the mirror. If it's falling 90 degree on the mirror, then what angle it's making from normal? Well, normal will going to coincide with the ray. 0 degree angle it will be making, right? So what should the reflected ray must make? It must also make 0. It bounces exactly along the same path. So always remember an important concept. Whenever ray falls at 90 degree to a mirror, they always go the same path. They just retrace it. They don't go at any angle then, because angle is 0. All right, so finally, this is how this ray goes back, and the other ray that is going back is here. Now you are standing in front of the mirror. Here is your eye. You observe these two rays. One is this, and one is this. Our actual object is this LED. So what your brain will do? Your brain will try to trace the path for these two coming rays. So this ray already is extended behind. What about the other one? Well, that one your brain extends behind and sees that, well, it appears to be coming from here. And that's why a plane mirror always forms a virtual image, because to your eyes, it'll appear as if there is one LED in front of you, which you have kept in front of the mirror, and there is one LED which you can see behind the mirror. So one LED is there, which is what we call image. So plane mirror always forms virtual image. Important things to be noticed about it. If the object was kept at d distance, then even the image will be formed at the d distance only. So the distance at which you stand from the mirror, what you see inside the mirror also appears to be at the same distance. If you walk by x distance, if object walks by x distance, even the image would walk by the same distance x towards the mirror. Both walk towards each other. There's also an important point. Image and object always walks towards each other. All right. These are the important things that you need to keep in mind. Here, the same thing is shown by some animation. As you can see, as I'm moving object, see how your eyes see the image, how your brain conceives the image behind. All right, so you must be clear by now. Important points to notice here. The distance The image and the objects are at the same distance from the mirror as what I discussed already. If you're at d distance, it's also at the d distance. The image size is the same as object. When you observe yourself in plane mirror, you always see yourself as it is. You don't see yourself enlarged or thin. That happens in other kinds of mirrors, which you see in usually in some fest or some circus kind of stuff, which are actually concave and convex. And you don't see any inversion in the image. You don't see yourself upside down. You see yourself as it is. All right, so now it's time that we move ahead with some question. So here comes the first question for you all. You can have a read. They say an object is 20 centimeter in front of a mirror, plane mirror. Mirror is moved 2 centimeter towards the object. Then what should be the distance between the positions of original and the final images? So, okay, at this point of time, you might want to pause the video and solve it for yourself. And here I'm starting with the solution. So you can unpause when you're already done with it. So let me try to solve this for you. So question clearly mentioned, object is placed 20 centimeter in front of the plane mirror. This is our plane mirror. An object is at 20 centimeter. And now the question mentions, the mirror is moved 2 centimeter towards the object. We are actually moving mirror 2 centimeter towards the object. That's how we're going to move the mirror towards the object. So what will be the new location of the image? Well, first of all, let's see what was the previous location. Previous location was 20 centimeter only. Here, let's call it I1, the original image location, right? And now when you move the mirror by 2 centimeter, what kind of thing will going to happen? So this is our location of the mirror now. What distance the object is at now? Object is unmoved. It'll be at 18, right? So the image must form at 18 centimeter only from the mirror. This is 18. But don't forget that the mirror has already moved by 2 centimeter. All right. Now they're asking you, this is by the way I2. They're asking you what is the distance between the original location of the image and the final location of the image. What is this distance? So remember, from here to here, the distance is 20. And what about this one? Well, that's 2. And what about this? What should be this distance then? Can you give a quick math to this? Well, I can clearly see it. The total distance now this is 20 plus 2, which is 22 centimeter. I guess all of you can see it. This 20 plus this 2, that's 22. From that 22, I just need to subtract the 18 and we're going to have this distance as 4 centimeters. That's the answer for the question. So this question all easy. Let's move to the next question. Here's the question for you. All right, again, you can pause the video, solve it, and here I'm giving you the solution. So there is a plane mirror like this, and there is another plane mirror like this. And the question clearly mentioned, a ray of light strikes the plane mirror PQ at an angle of incidence 30 degree. So this is, let's say, the incident light ray. What must be the angle of incidence? The angle of incidence should be this, 30 degrees. So at what angle it will going to reflect? Same 30 degrees is what we learned in the law of reflection. Then it will bounce off the second mirror. First question is, at what angle did it strike the second mirror? So you can see these two make 90-degree angle with each other. This is 30, so this angle has to be 60. And so when it bounces off, that should also be 60. So the correct answer for this question is 60 degrees. The final reflection angle is this theta is 60 degrees. So that's all for the concepts of laws of reflection and image formation by plane mirror. Thank you. Stay safe and enjoy. See you next time.